Alright, welcome back guys. Happy Valentine's Day. So today in class we went over a little recap of what we learned yesterday, as long as some new examples. So this video is going to follow that format. We're going to go over what we did from yesterday, and then we're going to go through some examples and even have a little bit of hints for your quiz. Okay? So what did we learn yesterday? So yesterday we learned about the surface area of rectangular prisms and how to label the rectangular prisms so you can properly substitute your values into your variables. So if we're going to label these two rectangular prisms, the height, remember, is always the part of the rectangular prism that's going straight up. So the height would be this part of the rectangular prism. Then we have length and width. The length and the width you can actually change, and we're going to talk about that in a minute. So let's just say, for instance, for this one, we'll say length, and we'll keep this one as width. So now we're going to change or label this rectangular prism. Remember, height, going straight up, this is your height. And now you can even change. So this will be our width, and this will be our length. So just remember, when you are labeling it, you can say that this is the length and this is the width. They're both right. But remember, the height is always going straight up. That one is a fixed value. You cannot change the height. The width and the length you can. So we're going to give you a real world example. So for instance, we are in a classroom. So follow me. So if I were to come into this classroom, the classroom has a fixed height. From the floor to the ceiling, that's the height. But if I come into this room, I can say that this long wall is the length, and the wall there with the windows is the width. However, if Miss Lamb was to come into the room, she would also agree with me. She would say the height is from the floor to the ceiling. That's a fixed value. We cannot change the height. But she could say that the long wall is the width, and the wall with the windows is the length. So we switch our values. That doesn't matter because they're interchangeable, the length and the width. However, we do agree on the height. So that's why when you're labeling your rectangular prisms, which are similar to rooms that we are in, the length is always going straight up, and we can switch the length and the width. Or the height's going straight up, sorry. So I also asked, why can using a net be useful? So here we have a net of a rectangular prism. So if I were to fold it up, we have a rectangular prism. So now I have to figure out, why is it useful to have one? So it's useful because we can see why it works with the formula. So as you can see, the formula is a bit low. That's right here. I'll show you guys again later. So if we're looking at the faces, we have 1, 2, 3, 4, 5, and 6. If we're just looking at it, we can see that face 1 and 3 are the exact same area. Face 4 and 2 have the same area. And 5 and 6 have the same area. So if we flip it around, I calculated the area for you for every rectangle. So like I said, 1 and 3 have the same 75 centimeters squared area. 2 and 4 have an area of 105 centimeters. And 5 and 6 have the same area of 35 centimeters squared. So that's where the 2 comes from in our formula. 2 times length times width. We could say it's like this. So we have length times width, and we have 2 rectangles that have the same length times width. So that's why in your formula we have 2 length times width, 2 length times height right here, and 2 height times width. So this rectangle and this rectangle. And there's your formula right there. Okay? So now that we've done a recap of what we've gone through, let's do some examples. Okay. So for most of your examples, you'll be given a rectangular prism. You'll have to tell me the height, length, and width that you use and properly substitute them into your formula. So let's go ahead and label it. So for our height, I want you to pause and label it and then come back. So for our height, the part of the rectangular prism that's going straight up is our height. So we'll label the 5 centimeters as our height. Then we have width and length. This one you can change, it's interchangeable. So let's say for now our 2 centimeters is our length and our 8 centimeters is our width. Okay? So the next step, once you have your formula and you've labeled all of the rectangular prisms, you have to substitute your values back into the surface area formula. So let's go ahead and do that. So if you want to pause it and come back to make sure that your answers are good, this is where you pause. Okay? So let's go ahead and substitute. So surface area is 2. Then you have length times width. So what would you substitute in there?
I would substitute 2 times 8 for the first one.
So 2 times 8, length times width. Length is 2, width is 8. So we're going to put 2 times 8. So for the next one, we have length times height. What would you substitute there?
5 times 2.
Okay. So I've noticed that you said 5 times 2. But when you're doing these examples, I want you to properly substitute into the variables. So our length is 2 and our height is 5. So it actually write it as 2 times 5. And our final height times width, what would you substitute?
So that would be 5 times 8.
Great. So now you kept the order the same. I ran out of room, but there's an 8 there, so just keep going with that. So our next step, let's find out what the brackets equal, okay? So surface area equals 2 times 8, 16. 2 times 5 is 10. And in that bracket it says 5 times 8. You just can't see it, I ran out of room. So 5 times 8 is 40. So now that you've figured out all the brackets, you're going to multiply the 2 into each of the brackets. So 2 times 16 is 32. 2 times 10, 20. And 2 times 40 is 80. So our final answer, you just have to add up all the numbers. So we're doing some mental math here. 80 plus 20 is 100, plus 32, 132. But remember, you have to include units. So look at the units that already came with the dimensions of the rectangular prism. So for this one, centimeters squared. So hopefully once you paused the video and went through the example, you came out with the same answer. So we're just going to keep practicing this over and over. I really want you guys to get substituting the correct values and actually labeling the correct height, length, and width. So this is another example of a question that you could get where I just give you a net. So let's use our net that we have here. It's not the same numbers, but we can just use it so you can see the concept. So on the board, you have a net that looks like this. So it's telling you the flaps here, so the flaps are 4 centimeters. So if you see the dotted line here, that's the part that folds up. So if it's folding up and you have a part of the rectangular prism is going straight up, that tells you that that's your height. So your height for this question would be 4 centimeters. So we're just going to write that down. Okay, so we're going to keep our height as red. And then length and width, like I said, you can interchange them. So we're going to keep length as 17 centimeters, so that's going to be green. And we'll make our width 10, so we'll make that blue. So once you've labeled it, substitute, 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 okay? Make sure you're substituting them into the correct variable. So we're going to do that now. We're going to show it with colors, just so you know exactly where all the numbers are coming from. Okay, so surface area equals 2. So we have length and width. So we said our length is 17, which is green. And we said our width is 10, which is blue. Okay? So from now on, we just move on. So we have length times height. So our length is green, 17 centimeters. And our height, like we said, is 4 centimeters, and it's red. So I'll substitute those in. Okay? So I'm just going to go below the line just because I want to run out of room and I want you guys to see it. But yours will just be one continuous line. So I'm going to go plus height times width. So our height is 4 centimeters. So we're going to sub the 4 centimeters into where the height is. And our width is 10 centimeters, which was blue. We're going to put that there. Okay? So hopefully the visual of the colors helps you notice exactly where we're substituting and that they are going into the direct variable, okay? So, same thing. Now we're going to do the brackets, then multiply the 2, and then finally add it all up. So for our first bracket, we have 17 times 10. You guys can use a calculator. Don't worry about doing this in your head. You will have calculators for your quiz. So 17 times 10 is 170. 17 times 4 is 68. And 4 times 10 is 40. And we're just going to pretend that says 40 there. I ran out of room again. So we're going to multiply in the 2. So 2 times 170 is 340. 2 times 68 is
136.
136. Sorry, can't do that. Those were the big ones in my head. And then 2 times 40 is 8. Okay? So once you're here, just add up all the numbers. So your final area will be, or surface area will be 556 centimeters squared. Okay? Make sure, don't forget to write your units. So now we're going to go to an example where there's a girl actually painting her room, and there's 3 ways you can solve it. So we're actually going to tell you the 3 ways, and on your quiz we would tell you which one of the ways we want you to solve it. You wouldn't have to do all 3. So let's go to it. Alright, Sabrina, she's painting her room. She's got a huge room, with a height of 10 meters. This girl's got ceilings for days. Alright? A length of 8 meters and a width of 5 meters. So the question is saying, how many square meters will Sabrina be painting? But usually when you're painting, you just paint the walls. But because I didn't state, I just wanted you to calculate the surface area of the walls, you're going to calculate the surface area for Sabrina painting the walls, the ceiling, and the floor. So that's one option. So I'll put your options here. So walls, ceiling. I think that's wrong.
Yeah. I prefer you.
I am not
Except
an
after C.
English teacher. Let me just tell you that. Oh. Alright, that's not working, but okay. And floor. Okay? So that's option 1. So I would actually tell you which option I want you to do. Just don't worry about that. So the second option, Sabrina's going to paint a normal house and just paint the walls. There's a third option, so I'll write it over here. She can paint the walls and the ceiling, but not the floor. Alright, spelled right there. Check that out. Alright. So we're going to go through how to solve for each of these options. hint, hint, this could be a test question, so pay attention. Okay. So our first option, we're going to solve it the same way we did in class. We're counting that Sabrina is going to do the walls, ceiling, and floor. So the first thing I would do is actually draw out the rectangular prism just so you can visualize what she's doing. So let's draw this rectangular prism. Okay, it's more of a cube, but you get the idea. So it's telling us the height of 10 meters. Always label the height first because it's the easiest one to do, okay? Height, straight up, and it's telling us it's 10 meters. So alright, 10 meters. And you have a length of 8 and a width of 5. Again, they're interchangeable. You can choose which one you want to work with. So let's say the bottom here is the length, so I'll say it's 8 meters. And on the diagonal is your width. Okay? So now that you know all of your variables, substitute it into your formula. So let's do that. So length is 8. Width is 5. Again, length is 8. Now your height is 10. Your height is 10. And your width is 5. Okay? So again, like we usually do, solve brackets, multiply by 2, add it all together. So I'll just do this quickly. If you're going to pause it, just make sure you follow along, pause it, and do the example before you actually see the answers to it. So again, multiply the 2 into each of the brackets. So 2 times 40, 80. 2 times 80, 160. And 2 times 50, 100. Okay? So we're just going to bring the answer up here for more space. So once you add them all up, you get 340 meters. So now notice it's in meters. So your surface area is 340 meters squared. Okay? So I was solving for option 1, which is painting the floor, the ceiling, and the walls. So I'm going to go to option 2. She's just painting the walls. So let me show you a visual. So let's pretend this is Sabrina's room. If she's just painting the walls, she's going to be painting face number 6, face number 3, face number 5, and face number 1. So she's painting the outside. But she's not painting the ceiling, which is face number 4, and she's not painting the floor, face number 2. So we have to figure out a way to find the surface area of just the walls and not the ceiling and the floor. So I'll show you that quickly. So, if you notice with this rectangular prism here, if we're finding the surface area of just the side faces, the height is always incorporated. So if we look at our formula, these two both have height in them. So these two variables of the equation have to stay in there because the height is a part of every single equation there. But the ceiling, which would in the floor, would just be measured by length and width. So because we're getting rid of length and width, we can actually completely erase this part of our formula. Okay, so does that make sense? I'll go over it again. So Sabrina's just painting the walls of her room. She's not painting the ceiling, and she's not painting the floor. The ceiling and the floor are like a normal rectangle. There's a base, and there's a length, width, but there's no height. But all the other walls have a height associated with them. So we keep these two from the equation, but we can get rid of this one. Okay, so this one is the floor and the ceiling. So let's substitute it in. So I'll just draw it again. So we said